today is Friday and we're going to go over the red teaming track. Actually, we're going to carry over what we have accomplished in the previous videos. So basically here, today we're going to go over evading logging and monitoring. Reminding you guys that I have a separate playlist for this track. You can go over this playlist if you want to watch walkthrough of the previous levels or previous rooms. So before we go over and discuss or solve the questions of this room, first let's discuss the concepts and the foundations it lays down. So the concept of this room is clearing tracks after you have compromised and accomplished your objectives on a machine. So remember guys that it all starts with the reconnaissance. So it starts with the recon, and then you actually exploitation, and then after you get access to the machine, you actually do persistence, maintain your access to get back to your target whenever you want. Then you do actions on objectives. And lastly, you may be required to clear tracks. It depends on the engagement. So that's how pen testing starts. So today we're going to discuss clearing tracks. Usually, when we think of clearing tracks, we want to learn ways of clearing our tracks depending on the target OS. So it could be Windows, and there are different ways to clear tracks on Linux and Mac OS. Okay, today we're going to discuss in Windows. Okay, since this is the most popular Windows operating system and it's the most widely used in the corporate world. So in any organization or in any setup, the machine that you have got access to, okay, has event logging activated. So usually here, there are two ways to activate logging to a certain machine. Let's say it's a Windows machine, and we're gonna say it is a client machine. It doesn't serve the role of a server. So there are two ways this machine is logging the activities. First one, using the event logs, and the other one is where the event logs are forwarded to syslog server, or it could be forwarded to SIEM solution. Nevertheless, here we're going to call this centralized logging. So it's centralized. So let's talk about the first one. The first one here, the logs of the events are generated and stored locally on the machine. Okay. While in centralized logging, still the logs and events are stored locally on the machine, but a copy of these logs is forwarded to a centralized logging server. It could be SIEM, Splunk, an example, or it could be a regular syslog server. So it depends on the setup. But put in mind that when you get access to a Windows machine, okay, you have to consider how to clear your tracks and bypass the event logging. Because let's assume that an attacker has got access to a Windows machine, okay, and the attacker started to execute system commands. They started to do who am I and dir to list the contents of directories. They started to maybe use mimikatz. Okay, all these commands, whether executed in a PowerShell session or CMD session, they will all be stored in the event logs or forwarded to a syslog server. In some situations, both cases are actually implemented. So all of the commands you execute on a machine, okay, are logged on the machine, and a copy of these logs is forwarded to a centralized logging server. Now, if this is the case, there is no way you can bypass the event logging unless the logs are only stored locally. If the logs are only stored locally, you can then, let's say, if only locally stored and not forwarded, you can then, after you finish, you can clear the logs. So if you clear the logs, well, yes, the logs on the target machine will be actually deleted or cleared. But again, if they are being forwarded to a centralized logging, every single command you type on the terminal or in a Powershell session will be logged and forwarded to a centralized server as you type it or as you execute it. So put this in mind when you actually craft your escape strategy. We have two methods of clearing tracks. The first one is clearing logs, and the other one that we will discuss, which is more effective, is disabling delogging altogether. Now we discussed that the first one works only when the logs are stored locally, are locally stored. Now the other one will work in both cases, local or remote. Why is this? Because when you first get access to a machine and you disable the logging, all the commands that you type, okay, will not be logged. It doesn't matter if the logs are stored locally or forwarded in that case. So Windows handles event logging through something called the ETW. So ETW stands for Events Tracing Windows. So it is the event tracing that we need to disable here. If we disable event tracing for the machine we have got access to, we will be able to effectively clear our tracks. So what are the components of the event tracing in Windows? The first component is the event controller. We must understand these components to effectively handle the clearing logs all the time. And the other one is event providers, and the last one is event consumers. Event controller is the component of the event tracing responsible for building and configuring the events. So this specifically means the event controllers are the components responsible for setting the size of the log file, enabling the logging, disabling the logging. So it's responsible for the main settings. Event providers are the applications that generate the logs. For example, Powershell is an event provider. SysMonitor is an event provider. These are some examples. So any application that generate logs called event provider. And the last one is event consumer. Event consumer is the component that allows you to view the logs. In Windows, one of the primary event consumers is event viewer program. Let's talk about some of the most popular event IDs that we need to be aware of if you want to clear our tracks. The first one is Windows Security Audit Log was cleared. It is event ID 1102. Typically, this event is generated when the audit log is cleared. the log file was cleared, the event ID is 104, the Windows event log service was shut down, is 100 or 1100. You want to check these logs if they exist after clearing your tracks. Okay, you don't want to trigger these event IDs because the machine might be monitored for these events IDs, and if they are generated, an alert will be sent to the blue team or the SOC analyst, and they will be alerted of your activity. That's why it's not advisable to clear your tracks, because if you clear your tracks, okay, these two event IDs, one of them will be generated, and therefore it will alert the blue team. Additionally, it's not recommended to shut down the log service because it will also generate an event ID that will alert the blue team. So if you generate these log IDs or event IDs, you will have successfully failed clearing your tracks. Just saying this. Now, additionally, we have PowerShell script block execution and command invocation. These are the two event IDs that we will also discuss in this video. So these two IDs are generated whenever you execute a script block or a single command in PowerShell. Sometimes your access to a target machine will be through a PowerShell session. So you need to be mindful of the commands that might be logged if you execute an entire script block or a single command. These event IDs will be generated. Okay, so the methodology, as we mentioned earlier, we don't want to trigger these event IDs. Okay, so we're gonna stay away from clearing the logs and disabling or shutting down the log service. We're going to disable the generation of these two event IDs. Okay, we don't want our commands to be logged. So to do that, we're gonna have to discuss methods to entirely disable the event tracing in Windows. The first method will be through PowerShell reflection. PowerShell reflection attack. And the other method will be, again, PowerShell reflection, but through group policy editor. So what's the concept behind these two methods? In the first one, in PowerShell reflection, remember that, guys, we talked about PowerShell reflection in a previous video, and we mentioned that most of the system assemblies are loaded in a PowerShell session within the privileges of the current user. So basically, the ETU service, for example, the event tracing in Windows, all the providers are loaded as system assemblies, okay, in a PowerShell session. So when we use reflection, when we use PowerShell reflection, we'll be able to control these assemblies. And since event tracing uses these assemblies for the event providers, we will be able to use PowerShell reflection to query these values and disable it. Typically, we will be looking for TP SETW log provider. So this is a .NET assembly. Okay. We can query its value using PowerShell reflection. Okay. We want to set the value of one of its fields to 0. So it has a field called ETU provider. We want to set this to 0 using PowerShell commands. We're going to see how this works in a while. Now, for reflection through group policy object will effectively allow us to disable logging or disable script block logging for PowerShell. So a script block and command, or let's call it module logging. Remember, in a group policy object, we can enable the PowerShell logging by following the administrative templates and then to Windows components, and then win PowerShell. If you follow this path in group policy, and if you open the group policy editor and follow this path, you'll be able to enable or disable the script block and module logging in PowerShell. So that's exactly what we're going to do, but not through the GUI interface. We're gonna do it through PowerShell reflection. The first thing we need to do here is to check how many events we have that match the event ID 4104. We want to see the number. So effectively here we have 356 events. All right. So now if we execute a PowerShell command here, we're going to assume that this number will increase. Okay, so who am I? So we executed a PowerShell command, and next we're going to check on this number again. Okay, so as you can see, we have now 360, which means that the command we have executed has been logged. All right, so now let's go over the first method, PowerShell reflection, and query the relevant system assemblies for the event tracing. All right, so we're gonna first execute this command. Okay. Who am I? Let's copy that one more time. All right. So what we're doing here first, as you can see, we're using PowerShell reflection to obtain the assembly type of what? Of this one, PSETW log provider assembly. This is the main assembly of the event tracing Windows. We want to obtain the fields, the information. So we're gonna enter and store them at the log provider variable. And then let's see what happened. So we got an issue here with the command execution. Paste one more time. Okay. Gonna copy this here. Okay. Echo log provider. Okay. So it's not public and it is not serial. So we have now the property, or not the property, the assembly stored in the log provider variable. The next thing, we want to store a null value. Okay, to store a null value here, we have first to call this variable. Let's copy this command. I'm gonna paste it here because it looks like we have a problem copying the commands from Obsidian to the machine. Okay, so we have now a new provider, etu provider, and here we are calling the first variable we have created, which stores the properties of this assembly. And then we want to get the fields, as you can see, etu provider non-public static, and we're gonna store a null value inside of it. Just have no idea why this is happening here. Okay, so now, all right, so it worked now. So now let's echo etu provider. System diagnostics, eventing, event provider. That's fine. Okay, so effectively, guys, we are controlling now the event provider. We want to disable all the log generation from all event providers. The last thing we want to do here is to override the m_enabled field and set it to 0 as we discussed earlier. Can execute the third command here. So the value we have just stored in etu provider was this one, okay, the event provider. Now we're getting the field information of this and setting the m underscore enabled to 0, effectively disabling the event generation. Okay, now let's go back. Remember that the number of events that matched the event ID 4104 was 362. Let's execute the command one more time to confirm this number. Gonna copy this. Look, they are now 373. So why the number has increased? Because we actually executed these commands. 373. So it increased from 362, nearly 9 events. So why is that? The reason is obvious, guys, because all of these commands were logged, okay, and that happened before we disabled the event logging, which means there will still be some traces of your activity, okay. There will be no escape from this fact. That's why at least we want to hide the commands that we want to execute. So let's take a note of this number and let's execute an arbitrary system command. Who am I? And now check the number again. So it is the same 373 before we execute who am I, and after we execute who am I, the number stayed the same, which means, guys, we have effectively disabled the event log generation. So no matter the commands you type now in PowerShell, they will not be logged. dir, okay, cd desktop dir file agent. Yeah, we are not in Linux. Let's now re-execute this one and see how many events generated. We should get the same number, 373. So we have disabled the event logging successfully using PowerShell reflection. Let's now discuss the other method, which will be through the group policy editor. Before we execute this, let's first get the number of events that match the ID 4104. So we have again 346. I resetted the machine. Who am I? Execute one more time. 350. All right. So right now, let's go with the PowerShell reflection through the group policy object. Okay. So here again, guys, we use the reflection function to get the assembly type of the cached group policy settings. Okay. The next thing, you want to set this into a null value. Okay, now assumingly we have set this to a null value, we can echo group policy settings. Okay, so protected event logging, script block logging, so it's still enabled. Okay, so this is not enough. After setting the null value, we have to modify the provider or the generic provider to 0. So effectively, we want to set the script block logging and the command invocation, it's not here. We're gonna set them to 0. So back here. Okay, so group policy settings, and we're gonna call script block logging provider, okay, and set it to 0. So it's enabled. We're gonna set this to 0 here to completely disable it. Cannot index into a null array. Okay, let's try this one. Okay, and this is for the script block logging. We can also set the value to 0 for the script block invocation logging. Okay. And lastly, we're going to need to set the required registry value to the value we created here, which is under, as you can see guys, software policies, Microsoft Windows PowerShell, script block logging. Doing that effectively will disable the PowerShell logging. Cannot index into another. Alright, let's try now. Let's scroll up, copy this command. So the number of events was 350. We're going to assume that the number now has went up or gone up because of the commands we executed. So right now let's get the number of events. So it is 378. Who am I? And execute one more time. So 382. Still we have some traces. Now this method may not work if you execute these commands separately. That's why the room author here has crafted a full script called GPO bypass. So this GPO bypass just aggregates all of the commands we have executed here into one fully working script to bypass or to disable the PowerShell logging through group policy takeover. So all we have to do now is to go over the script and execute it. And then after executing the script, we're gonna do the same comparison. Check the number of events, or we're gonna execute the provided executable file here with the task that will tell us whether we were successful disabling the event logging or not. So let's take a look at the script. As you can see guys, the script contains the same commands we have executed individually in the PowerShell session, but they are just aggregated in one working script. Let's now go ahead and execute this. Okay, now the next thing, we're going to execute the provided executable file. Now this one might take some time, but at the end guys, if you have done everything correctly, meaning executing the script, you will get the flag of this room in the last task 10. Okay guys, so let's go over the tasks here and see if there are some questions we haven't answered. How many total events can be used to track event tampering? You already mentioned these guys, they are 3. What event ID logs when the log file was cleared? 104. Tracing instrumentation, no question needed, no answers needed. What reflection assembly is used? This is for the PowerShell reflection method. It is PSETU log provider. What log field is overwritten to disable ETU? It's m_enabled. Okay, this is the other method of patching EWT. We haven't talked about this because it's kind of practically not possible with this room. What is the base address? Okay, these questions can be answered from the current task. How many total events are enabled through script block and module providers? There are 2. What event ID will log script block execution? 4104. Typically easy questions guys, and lastly you will get the flag once you execute the attached executable. So guys, that was it.